Hey, good morning, everybody. This is Mr. Aynesworth again, and we're in here in part 4 of our series of graphing and understanding the reciprocal functions. All right, in this video here, we're going to be talking about the cosecant function, which is the reciprocal of sine, okay? So the first thing we're going to do is we're going to take the y-coordinates of the unit circle, all right, which represent the sine of theta, and we're going to reciprocate them as you go from 90 to 180 degrees. Okay, so what in the world does that mean? So let's take a look here. So we're going to go from 90 and we're going to rotate counterclockwise. And we are going to take a look at the y values now and see what happens when we reciprocate them. Okay, so starting with rad 3 over 2, root 2 over 2, and then 1/2. What happens when we reciprocate these numbers? Okay, and I did something like this in the previous video here. So here we go again. All right, so let's take a look at rad 3 over 2. All right, we're going to take the reciprocal of it. REC stands for reciprocal right there. And if you do that, you get 2 divided by rad 3. And if you remember from the last video, that's about 1.15. Okay, you can verify this with decimals if you like. Okay, the next y value at 135 degrees. All right, the reciprocal is root 2 over 2, and the reciprocal of that is 2 over rad 2, which, if you rationalize it, what do we get? If you rationalize that, you get root 2, actually, which is about 1.4. And the last one, the easiest one here, if you take 1/2, reciprocate that, you get 2, okay? And notice what's going on with these values here. When you reciprocate all of these numbers that are less than 1, okay, and all of these are less than 1, they have to be, they're on the unit circle, right? And the unit circle, well, guess what? The radius is 1. So all of these numbers here, every single number on the unit circle is less than 1. Well, except 1, that is, okay? But I'm talking about not at the quadrantal angles, okay? I'm talking about the numbers in between the quadrantal angles, all right? In between 90, 180, 270, and 360. All right, so all of these numbers are less than 1. When you reciprocate them, you get numbers bigger than 1, all right? They get bigger and bigger, and they're all bigger than 1. So I'm talking about these numbers here, the 1.15, the 1.4, two things. First of all, okay, they're getting bigger, and they're all greater than 1. So they're getting bigger. That's the first observation. All right, and they are all greater than 1. That's what happens when you take the reciprocal of a small number less than 1. You get a number greater than 1. How about that? We talked about that in the previous video. All right, now let's get into it. So here we go. We're going to take a look at the domain of cosecant. And the way we do that is by writing down the definition. All right, so cosecant of theta is defined as 1 over sine theta. Okay, and as I've said before, you can never divide by 0, right? You should know that by now. You can never divide by 0. Believe it or not, you got to go back to grade school to understand this lesson right here. And because of that, sine of theta, whatever it is, it can never be equal to 0, which implies that theta cannot be equal to 0, pi, okay, 2 pi. You've seen me do this many times, 3 pi, 4 pi, etc. So theta cannot be equal to k pi, where k is some integer, okay? And I'm talking about 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. Okay? So that's the domain. Okay, slash this right here, not equal to. So this is the domain, but it also gives you information on where your vertical asymptotes are. And that's how you always start. You always analyze the domain first, and then you plot your vertical asymptotes at 0, pi, negative pi, 2 pi, negative 2 pi. You can be negative. All of these can be negative as well if you want to go to the left of 0. And then you graph it from there. It's got to exist between these asymptotes. Okay, so I'm going to draw them in here first. Okay, you see me do this in every single video. So I got a asymptote at x equals 0, and then we've got one at pi. Put sound effects in. All right, so I got another vertical asymptote at x equals pi. And then I'm going to be drawing multiple periods here. So There's another one at x equals 2 pi. And if you wanted to graph more, you could. Okay, so now we're gonna plot sine first, and then see what happens. And I'll plot some points here for the cosecant function. So you'll see why I have you plot sine first. If you remember back in my previous video, we did this for secant. I asked you guys, or I showed you, I plotted cosine first. Well, now I'm going to plot sine first. So here we go. Sine of 0 is 0. Sine of negative pi halves, I'm going to go backwards here too, is negative 1. And then sine of pi halves is 1. Sine of pi is 0. Sine of 3 halves pi is negative 1. See, you guys should know all this by heart. So what I'm doing right now, these are all masteries right here. And you have to know the sign of all these values by heart by now, because we've been practicing so long. And you should be able to reproduce this at any time you need to. Okay, so there's your sine function. And notice that the range of sine, as you guys know, is from negative 1 to 1. But watch what happens when you take a look at the reciprocal function called cosecant. Okay, watch what happens. Here we go. All right. So now what I'm going to do is I'm going to take the cosecant of 0. Cosecant of 0, that's 1 divided by the sine of 0, which is 1 over 0. And guess what? That's undefined. So I just found my first asymptote in the table right here. So boom, that's why we have a vertical asymptote at x equals 0. Okay. This is the x-axis now. I know I said theta, but it's basically the x-axis when you graph it. And then what's the rest? Well, let's see here. Cosecant pi fourths. This is why I gave you guys that mastery. I think it was like mastery number 7, where you guys had to evaluate all 6 of the functions at different angles. Because if you don't know your values, you can't do this, and what I'm saying won't make any sense. That's why I did it a while back, about a week and a half ago, because you got to get good in order to stay on the basics. Now this is 1 divided by sine of pi fourths. Now that's rad 2 over 2. Okay, remember you can look at unit circle, or you can just look at this right here, this 45, 45, 90 right here. So the sine of 45, or pi fourths, is 1 over rad 2, right? Or root 2 over 2. But it's 1 over rad 2 on this triangle, opposite divided by hypotenuse. So, got DOA. It's that simple, believe it or not. And then if you reciprocate 1 over root 2, you just get root 2, which is about 1.4. So notice it's out of the range. It's above this sine graph. Okay, that's why the cosecant function, the reciprocal function, is above and below the sine curve, as you're going to find out. All right, next, you get cosecant of pi halves. That's 1 over sine pi halves. Well, what's that? Well, that's 1 over 1, right? Which is 1. And then next one, cosecant of 3 pi fourths. That's 1 over sine of 3 pi fourths. That's quadrant 2. Okay. And that's coterminal with pi, not coterminal, but that's the reference. The reference angle for 3 pi fourths is pi fourths. So I know that the sine of 3 pi fourths, well, that's the same thing, 1 over rad 2 again, because the reference angle is pi fourths. Okay, and the reciprocal of 1 over rad 2 is root 2. So this is rad 2, or about 1.4. So, which is greater than 1. It lies above the sine curve. And then that last one, cosecant of pi, that's 1 divided by the sine of pi, and that's 1 divided by 0, and guess what? That's undefined. Okay, we just found the second asymptote right here. So that's why we have an asymptote at x equals pi. Okay, so now we got to plot these babies. So let's do that. All right, so here we go. I'm going to plot the cosecant function in blue. And so the first one I plot is at pi fourths. And at pi fourths, we go up 1.4 units. And again, this is 1.2, 1.4, 1.6, 1.8. See, that's why I organize the graph like this. So pi fourths go up 1.4. Pi halves kind of up 1. And then 3 fourths pi go up 1.4 again. And you can see it kind of lives in through here. It's not a parabola, okay? So some people think it's parabolic, and it's not. Okay, it's hard to draw the shape, but it's not parabolic. It's just curved like that. And it's asymptotic to these red dotted lines called asymptotes. Okay? And the next one, it's going to appear down here, but between pi and 2 pi, it's going to go down below at 5. It's going to be about negative 1.4 here, and then here, and then here. And it's going to behave like this, but it's going to go in a negative direction. And we're going to verify that with decimals. So there's one period right here. Again, the distance here between the two, any two asymptotes is pi. Okay, and there's another pi here, so pi plus pi is 2 pi. So the period here, the two parts of the curve that you're looking at in blue, which is your cosecant curve, cosecant x right here. So blue is, I'm going to spell it right here, cosecant, there you go. Cosecant x in blue here, it's part of it goes up, part of it goes down, and then repeats infinitely. So the period is 2 pi. So period is 2 pi, not pi, but 2 pi. The domain, as I said above, is all reals not equal to all of these asymptotes. Pi, 2 pi, 3 pi, etc. All right. Or you can say x is not equal to k pi if you want to write it in a fancy way. Make sure you say that k is an integer, though, if you do it that way. And then the range, again, just like the previous function, the secant function, okay, the upper portion, y values are greater than or equal to 1, and the lower portion, y is less than or equal to negative 1. So if you want to write it like that, that's fine. So y is less than or equal to 1, or y is greater than or equal to positive 1. Or using inner notation, you can go from negative infinity to negative 1 closed, or, all right, 1 closed on the left, open on the right to infinity. All right, so the reciprocal of numbers less than 1, which exist on the sine function, become greater than 1 on the cosecant function. And that's what I did initially right there. So whenever you deal with reciprocal functions, you really have to understand the numeric nature of what's going on right here. And remember, all the values on the sine function are between negative 1 and 1. They're fractions or decimals. When you reciprocate them, you get numbers bigger than 1 or less than or equal to negative 1, so it opens down. And that's why when you go to Desmos here, which is here, enter in the sine function and the cosecant function, and enter in all the asymptotes like pi, 2 pi, and 3 pi like I did. Right through here, save all your work too. And then click on your maxes and mins, and you'll notice that this cosecant function lives at the max and mins just like your secant function. Okay, and that's why you'll see all instructors say, hey, go ahead and sketch the sine function first. Again, in purple, you'll see your sine function. And then at the max, you'll have a portion of the curve, and at the min, you'll have the other portion of the curve going down. So sketch the sine function first and the asymptotes, all right, and then you can sketch your cosecant function. And there you go. And that's it. And then validate everything with Desmos here. All right. I'm Mr. Aynesworth. This is part 4, and I will see you in my last and final lesson here. This is going to be part 5, where we apply what we've learned, and we do all kinds of cool application problems. Okay? So hopefully that helped you out. I'm Mr. Aynesworth. I'll hopefully see you in class. Take care. Bye-bye.